All right, so where we left off, we were right here. We had just said angle JAM is congruent to MAY. So JAM right there is congruent to MAY. MAY is right there. Also KAM, which is right here, is congruent to MAD, which is right here, the one tick mark, the one tick mark. I'm trying to make the division property work here, but keep in mind with the division property, we're taking that larger angle. So like the measure of angle JAM, it's been bisected, right? We divide it. The problem is JAM, the larger angle, has not been bisected, right? So when we divide that by 2, it's not like JAM divided by 2 equals KAJ. We don't know that. So what's been bisected is JAY, that's the largest angle, and also the smaller angle KAD has been bisected, but JAM, which is what we need to be bisected to use the division property to give us KAJ congruent to DAY, that doesn't work, right? So this does not necessarily equal to the measure of angle KAJ. So we can't use the division property, but here's what we can do. Watch this. What is the measure of angle KAJ equal to? Well, it's equal to the measure of angle JAM minus the measure of angle KAM. And let's compare that to the measure of angle DAY. What is DAY equal to? It's equal to the measure of angle MAY minus the measure of angle DAY. So JAM and MAY, they're congruent. KAM and DAY, they're congruent. So when congruent angles are subtracted from congruent angles, their differences are congruent. So we are able to conclude that angle KAJ is congruent to angle DAY, and that reason is the subtraction property. So that one's a little tricky because you're thinking, oh, something's been bisected. We're going from larger down to smaller. It's going to be the division property, but the way this one shook out, the larger angle, the angles that were bisected didn't allow us to solve for KAJ. So that's why we had to go with subtraction property on this one. And here's the support over here. All right, number 22. E is the midpoint of RD. That means RE is going to be congruent to ED. Also, we know that RE is congruent to HE, so HE is congruent to RE, and ED is congruent to EN. We're trying to show that E is the midpoint of HN. Well, as you can see when I use the tick marks, we can see clearly E is going to be the midpoint. But let's put it into a proof. Okay, so first off, let's get it going here. Statements and reasons. Number 1, E is the midpoint of RD. That's given. What does it mean for E to be the midpoint? Well, it means that RE is congruent to ED. That's going to be the definition of midpoint. Okay, so let's show that. RE is congruent to ED. Number 3, RE is congruent to HE. So 3, that is going to be given to us. Oh, excuse me. So if RE is congruent to HE, there we go. Statement number 4, ED is congruent to EN. That's given. Let's use our tick mark there, right? DE is one tick mark, EN has to be one tick mark as well. What are we able to conclude? We're able to conclude that, let's see here, we got to use some substitution, right? We're able to conclude, let's say, we're going to use substitution. going to say that RE is going to come out, HE is going to go in its place. So HE is congruent to ED. Okay. Okay. That's substitution. And also, so remember, we're trying to show that HE is congruent to EN, and we can now show that HE must be congruent to EN through substitution. And then finally, we know that E is the midpoint of HN. E is the midpoint of HN because the definition of midpoint. All right, guys, that's all I have time for. The bell is rung. I've got to get to class. I'm assuming you can figure 23 through 26 out from the key. But thank you very much for your attention and time. Good luck on your test.